Sometimes only part of a Boolean expression needs to be evaluated to determine if the entire expression will be true or false. In this first example, if A has the value of true and we have the expression A or B, we know that we only need one or the other to be true in order for this whole expression to evaluate true. So when A is true, we don't really care if B is true or false. The entire expression is going to evaluate to true. We might, as humans, skip that step of evaluating B and go ahead and say the entire expression is true. The computer does a similar thing, and it's called short-circuiting or lazy evaluation. In this other example, we have if A is false, and then we have the expression A and B. Since we know that with the AND operator we need both A and B to be true for the entire expression to be true, then if the computer sees that A is false, it goes ahead and determines that the entire expression is going to be false. So this is a way to save time and be more efficient. Note that if A had been true here, the computer could not have short-circuited, right? Because if A was true and we need both to be true, then it has to look at B to determine whether B is true or false to see if this entire expression will be true or false. So here's the truth table to determine what A and B would evaluate to, given all the different combinations of A and B being either true or false. So let's determine which one of these rows will cause the computer to short circuit, if any. So in this first row, A is true. Since we need both A and B to be true, then we have to go look at B. The computer doesn't short circuit. The same thing in this next one. When A is true, then it says, oh, well, we need to go see if B is true or false. In this third row, we have A with the value of false, right? And so we know that this entire expression is going to be false just because A is false, because we need both to be true. So this row here will cause the computer to short circuit. And finally, we have the same case here. Once we see A is false, there's no need to check if B is true or false because this row here will also cause the computer to short circuit. Now let's try to determine when the computer will short circuit for A or B. So again, for or, I need either one or the other expression to be true. So if A is true, like in this first row, then I don't need to look at B. I know that this entire expression is going to be true. So the computer short circuits. The same thing for the next one. A is true, so no need to check B. We know the entire expression is going to be true. In both of these last two rows where A is false, we need to go check B to see if it's going to be true or false. What about for the exclusive OR? Can we ever short circuit with the exclusive OR? Remember, the difference of the exclusive OR is that I want either expression to be true but not both. This means that I really do need to check both expressions. If this value of A is true, then I need to go make sure that B is not true, and vice versa. If this value is false, I need to go make sure that this value is true and not false in order for the entire thing to be true. So we can never short circuit when we're using the exclusive OR. Sometimes this short circuit evaluation can be essential, can be very helpful to us, like helping us avoid a runtime error. In this if statement here, I have if sum divided by number is greater than 5. This could possibly produce a runtime error because we're dividing by this variable here called number. And let's say that we're getting that input from the user or we're computing that earlier in our program. It could have the value of 0. And we know that anytime we try to divide by 0, it's going to crash our program, right? So now that we know about short-circuiting, we can utilize this to write this if statement a little bit differently and prevent a possible crash of our program. So now if I say if number is not 0 and then my division here by number, we're going to actually use short circuit to prevent crashing the program. The reason being that since I have this AND condition, if this first condition on the left ever evaluates to false, then the computer will skip this condition on the right. And we can use that to our advantage because if number was 0, then number not equal 0 would evaluate to false, right? So again, this was crafted very carefully. So as soon as this becomes false, if number is 0, then the computer skips the evaluation of this line and therefore skips over the line that would cause our possible runtime error. So now we're going to change directions and learn about a new kind of branching statement called the switch statement. The switch statement allows us to branch in multiple directions and can often be substituted in place of using the traditional multi-branch if-else statements. We begin by using the keyword switch, followed by a set of parentheses that contains a controlling expression. This controlling expression is different from a Boolean expression that we're used to, so we're not trying to put something that evaluates to true or false inside these parentheses. In fact, we have a very limited number of things we could put in there. We can put an int, or anything that evaluates to an int, a char, or a string variable inside of these. Notice that my switch statement is then followed by a set of curly braces. Within these curly braces, we're going to enclose a set of cases. These cases are the possible values of the controlling expression. So if I had an int as my controlling expression, like number, then I could say case 1 as my case label. So I'm basically saying if number is equal to 1. So the different cases that your controlling expression could be. Each case begins with the keyword case and then followed by a case label. The case label is then followed by a colon and then one or more statements that you want to execute. If the value of the controlling expression matches the case label of the particular case, then those statements will be executed. Notice the break statements here after each case. These break statements cause the execution of the switch statement to end. If left out, then execution would continue on to the next case, regardless of what the case label here is and if it matches, and your switch statement is not going to work as you expected, so you must include these. You can add a default case that's executed if no other case is matched. This is kind of like the else statement in our multi-branch if-else. These are not required, so your program will function when you leave the default out, but they're strongly recommended even if it just prints an error message. So note my syntax here is to use the keyword default. I don't have a case label here, but I do have to follow it by the colon and then whatever statements I need to execute and a break statement. So let's go to Eclipse and look at an example. So here I'm going to create an int number that reads in from the keyboard. And then I want to write a switch statement that's going to switch based on this int variable number. And if the number is equal to 1, then we're going to print out the word 1. If it's equal to 2, we're going to print out 2, 3, and then we're going to use a default statement to say not 1 through 3. So I'm going to start out by using the keyword switch, and then remember I need to have a controlling expression, which is the expression that is controlling this entire switch statement. Number, this integer entered here, is going to be that controlling expression, and then I'm going to open and close my set of curly braces. Now I'm going to start creating my cases. Remember the syntax is that I use the keyword case, followed by a case label, which is the condition that we're trying to match with the controlling expression, and then followed by a colon. So my first case is that number is going to be equal to 1, so I'm going to say case 1, and system.out.println 1. Now don't forget that you must include break statements in order for this to function as you expect, so must include. And what these break statements do is they're going to end the execution of the entire switch statement. So on to my next case, we're going to say case 2, system.out.println 2, break, and case 3, system.out.println 3, break. Now I'm going to have a default statement, so remember we use the keyword default. There does not need to be a case label, but we do need to follow it with that colon. And by default, I'm going to say system.out.println not 1 through 3. Something like that, and I'll end it with a break statement here. Now let's run this just to see how it will function. So I'm going to run it with the value of 1. It should print out 1, the text, right? And it does. So the same thing would happen if I were to enter 2, 3, and if I enter any number other than 1, 2, and 3, like negative 75, it's going to say not 1 through 3. So now let's look at what could happen if you do something wrong, because we're not all perfect the first time around. So if I were to leave out a break statement, I'm going to just comment this first one out. If I run this with the value of 2, then it looks like it works just fine, right? So sometimes you can kind of get false positives here. It looks like your program works fine, but you haven't thoroughly tested it, because if I were to run it with the value 1 here, let's think what's going to happen. It's going to match that this controlling expression number was equal to 1, so we're going to print out the number 1, But because it doesn't hit a break statement, it's going to continue execution onto here. Note that it does not check the value of this case label here. It's going to continue execution no matter what until it finds a break statement. So after it prints out 1, it's also going to print out 2, then it's going to hit a break and end the statement. So again, if we run it with 1 here, you'll see it printing out 1 and 2. Now the same thing would happen if I removed this break statement, right? If I enter the number 1, it's going to print out everything from when this 1 was matched until it finds a break statement, so all of this. But if I were to enter 2, then it wouldn't go into case 1. It would print out just 2 and 3. Now, let me fix this to where it works as we expect. A good question might be, do I really need this break statement at the very end? Well, if I take it out and I run my program, I can run it with any number. I can run it with 1 and get the expected value, and I can run it with 10 and get the expected value. So you may be tempted to say, yes, we can take this break statement out. But the interesting thing about switch statements is that the order of these statements doesn't necessarily matter. So if I were to take this default statement and move it up to the beginning of my program right here, almost like it's the first case, and run it, if I enter the value of 5, you can see that because I don't have this break statement, it's going to work just like the others. If I did have this break statement, then if I ran it with the value of 5, it would work as expected. So you can put these in any order. You do have the condition that you cannot duplicate cases, so I couldn't down here have another case 3. You see already it's telling me an error, and that error is duplicate case. So you can't duplicate the different cases. So here we're going to practice a switch statement using this char variable called letter. So I created this variable, and it gets a string from the keyboard and then takes the first character of that string. And so we're basically just reading in the first character that a user gives us. So we're going to switch on letter as the controlling expression. And so I'm going to start my cases here. So I start with the keyword case. And then let's assume that they're either entering Y or N for yes or no. So case Y, so I enter it just like a char here. I do have to include the single quotes. And then my colon, I'm going to say system.out.println, yes. And then I must include my break statement here. And then case N, I'm going to say system.out.println, no, break. I'm then going to have my default statement here that says system.out.println, please enter Y or N, something like that, and another break statement. So if I run this with N, it's going to print out no, and so this would work as you expected. So let's take this one step further. We know that what we use as our controlling expression must evaluate to either a char, string, or int value. What this means is that I can't use a Boolean expression in here. So all of those different Boolean operators, like the less than symbol, the and, or the or, can't be used in this switch statement. So there are some limitations there. So for example, I can't use a switch statement to determine a range of values. I couldn't determine if a number was between 1 and 5. I also can't use the ampersand, but I can wiggle around and implement the or the very basic version. So given this little program that we created, let's say that we also wanted to print out yes if the user entered a capital Y. Now, I can't do something like this or capital Y. You're going to see that immediately it's not going to let me do that. So that will not work. But because we know how these break statements work, if I were to say case capital Y followed by a colon, then this means that if my letter was equal to a capital Y, then because I don't have a break statement, we saw that it doesn't check this condition, so it's going to print out yes, and then end the switch statement. So this actually does function as an or statement. I can do the same thing here for N. So case N. So case N. And if I run it, I will run it with a capital N, and you can see it still prints out no. So this is a way to implement the basic OR statements. So we've now seen examples of switch statements with integers and chars as the controlling expression, but we said we can also use a string as the controlling expression. So this is just a small example where I have a string language, and I'm going to switch based on that string variable. Notice here that just like I had to use single quotes with chars, I have to use double quotes for strings. So case English, I'm going to print out hello. I've got my break statement. Case Spanish, I print out hola, break, and so on and so forth. So as an overview about our switch statement rules, we know that the default case is optional but recommended even if it just prints an error message. We know that break statements are required to end the switch statement correctly, but we also know that we can utilize this lack of break statements to implement an OR statement. We saw that we cannot have duplicate case labels that will cause an error, and that the controlling expression must be a constant. Again, it can be anything that evaluates to an int, char, or string. And I say anything that evaluates to an int, char, or string because there's actually one other type that we haven't looked at that will work with switch statements, and these are called enumerated types. Enumerated types, or enumerations, allow us to specify a set of fixed values. For example, movie ratings have a set of fixed possible values, so G, PG, PG-13, R, or NC-17. So we can create an enumerated type called movie rating to hold these fixed set of values as seen here. So we use the keyword enum, short for enumeration, followed by whatever we're going to name our type. In this case, I'm going to call it movie rating. Then enclosed in curly braces, we specify the possible values separated by a comma. Note that we do not use quotations here because these are not strings. These are of type movie rating. Like constants, enumerations are declared inside the class but outside of any method. Once an enumeration is defined, you can create variables of that type. For example, if I wanted to create a movie rating for the movie Jaws, I could say something like movie rating Jaws equals movie rating.pg. So what I'm actually doing here is this variable Jaws has the type movie rating. We declared this as a type and now we're using it as a type. And then I'm giving this variable Jaws the value of PG. Note that we cannot simply say PG here as the value for Jaws. The correct syntax is to use the name of the enumeration, dot, and then whatever your value is. Each value of an enumerated type actually has an associated int value, like this would be 1, 2, 3, 4, and so on. This makes it easy for Java to handle these types. Since enumerated types are fixed values that evaluate to ints, we can use these as the controlling expression inside switch statements. So here I've got my basic branching class, and I'm going to first create that enumerated type of movie ratings. And remember, I'm going to create this inside the class but outside of any methods. So I'm going to use the keyword enum. I'm going to name my type movie rating. So I'm going to open and close my set of curly braces and then put all of my movie rating values inside here. Okay, now I'm going to create a variable of type movie rating. So I'm going to use movie rating as my type. I'm going to create this Jaws variable that we talked about. And then I'm going to set it equal to the value PG. Now again, remember I cannot just say PG here. I have to say movie rating.pg. Then we're going to create this switch statement that switches with Jaws as the controlling expression. So an enumerated type is the controlling expression. My different cases are going to be all the different possible values of this enumerated type. So my first possible value is G. So I'm going to say case G followed by the colon. Note that I did not need either single or double quotes because this is not a char or a string. And I'm going to print out general audiences. I will do the same for the rest of them, and it looks like this. So here you can see all the different cases. We print out the verbiage for each different movie rating, and we did include the break statement. I have a default statement here that just prints out error if none of the cases were matched. So to conclude our lesson about switch statements, let's leave off with a few questions. Can we use a switch statement with a Boolean variable? The answer to this is no, right? Because we saw that our switch statements need a controlling expression instead of a Boolean expression, and we have restrictions about what types we can use as a controlling expressions. It was anything that evaluated to an int, a char, or a string. And we saw that we could also use enumerated types as the controlling expression since those do evaluate to an int. When is it better to use an if-else statement than a switch statement? So this could also mean a multi-branch if-else statement. Again, we just said that we had a lot of limitations on what we can use as our controlling expression. So anytime I want to check if a number is in a range or if I want to compare doubles, then a switch statement is not a good choice. Is there anything a switch statement can do that a multi-branch if-else statement cannot do? The answer is no. You can always take a switch statement and turn it into a multi-branch if-else statement, but not the other way around. So can we get by just using switch statements? No, because as we've seen, there are some limitations where we would need to use a multi-branch if-else statement. That's all for this lesson.